Good morning everyone. Today we are going to discuss the topic about Wien bridge oscillator in analog electronic circuit. We're going to discuss about what is an oscillator, basics of Wien bridge oscillator circuit, working principle, advantages of Wien bridge oscillator, limitations, applications, and conclusion. So let us start with what is an oscillator. So an oscillator is an electronic circuit that generates a periodic oscillating output signal without the need of an external input. In similar terms, it's a device that produces a repetitive waveform such as sine wave, square wave, or triangle wave at a specific frequency. An oscillator is an electronic circuit that generates a periodic oscillating output signal without a need of external input. It produces a sine wave, square wave, or triangle wave at a specific frequencies. So, uh, an oscillator which consists of the characteristics of periodicity, stability, amplitude, and phase. So, moving on to the next slide, we have basics of Wien bridge oscillator. The Wien bridge oscillator is a type of electronic oscillator that generates sinusoidal waves. Here are the basic components. So, these are the basic components of the Wien bridge oscillator behind the operation of the Wien bridge oscillator, which are frequency determination, bridge network, feedback network, phase shift, sustained oscillations, amplitude control, frequency stability, and applications. These are all the basic principle or components of the Wien bridge oscillator. So let us move upon the next slide, which is the circuit diagram of the Wien bridge oscillator. So this is circuit diagram of the Wien bridge oscillator. The circuit diagram of the Wien bridge oscillator. This is the oscilloscope in which we are going to check out the waveform, and this is the ground, and this is the 12-volt supply, and these are all the components we have listed. And this is the transistor, which is a BC107 BP. We have two transistors which are connected together, and we have all the setup done, and this is the output waveform of the Wien bridge oscillator. So this is we have done in the simulation, which is NI multisim, which is called as National Instrumentation and Multi Simulation software, which is installed in Windows, and we have simulated the Wien bridge oscillator circuits, and this is the output with the sinusoidal wave. Upon it's a little bit more not so sine wave, but it is sine wave. So let us go for the next slide, which is working principle. The working principle of the Wien bridge oscillator involves the interaction between the bridge network, the feedback network, and the operation amplifier to generate stable sinusoidal oscillations. So these are all the working conditions for the Wien bridge oscillation to work. Initial conditions, bridge network, feedback network, positive feedback, phase shift, sustained oscillation, and output signal. These are all the things which is necessary to for working of Wien bridge oscillation. We have to keep all this in mind before constructing the circuit. Moving on to the next slide, advantages of Wien bridge oscillator. So, what are the advantages of a Wien bridge oscillator? Which has a precise frequency control. We can precisely or accurately control the frequency and low distortion, which is nothing but low, like it has some distortion and disturbance in the frequency, but it's less. It's going to reduce. And the simplicity, like it's not so complicated, and you don't need something more big construction. It's like simple circuit, and which does the precise frequency control and low distortion, wide frequency, like you can choose a number of frequency, and ease of implementation. You can implement like its simplicity, like ease of implementation, low power consumption, and it has more stability. So in limitation, despite its advantages, the Wien bridge oscillator also has certain limitations that should consider when designing and using this circuit. Some of the key limitations include frequency stability, amplitude stability, limited frequency range, sensitivity to component variations, complexity in component selection, power consumption, susceptibility to noise and interference. So these are not the disadvantages, as we have covered most of these topics in advantages. So these are just limitations, like frequency stability is limited in this type of circuit, but it's maintain the stability, but it's limited. Amplitude stability, it has amplitude stability, but it is limited. Like yeah, it has a number of frequency range, but not all. It's limited like that. So moving on to the application, the Wien bridge oscillator finds applications across various fields due to its ability to generate stable sinusoidal signals. Like upon we have discussed the advantages, like it produces stability, and stable sinusoidal waveform. So in application we will use it in audio signal generation, signal generator, instrumentation, frequency synthesis, medical devices, test and measurement equipment, communication systems. So these are all the applications we are going to use in vein bridge oscillator. So to the end of the slide, in conclusion, the vein bridge oscillator ability to generate stable sinusoidal signals with precise frequency control makes it indispensable in numerous electronic systems. Like as we already discussed, like advantages is precise frequency control, low distortion, simplicity, wide frequency range, ease of implementation, low power consumption, stability. So like these are all the things which are going to necessity limitations, advantages, and like applications and the circuit which I should just show. So like yeah, we're going to wind up this topic. Thank you.